Yeah. You are graphing exactly what your elbow partner had on theirs. Either or, I mean, at least one. Okay. All right, I need your eyes up here. Amelia, what graph did you have? Number 2, and your partner had number 1. So you took your graph and number 2, and then you plotted number 1 with a highlighter, right? So the graph number 1, oh, we had 5 for a y-intercept, and we had a slope of 4. So it looked like this. And then we shaded this way. Okay, so those of you who had 1 and 2 graphed together, this is what yours looked like. Who else had 1 and 2 together? Okay, so whether yours looks like this or you have 3 paired up with 4, 2 paired up with 4, 1 paired up with 3, 1 paired up with 4, 2 paired up with 3, doesn't matter. What do you notice about when we graph 2 of them together?
Some of them shade over each other.
Oh, some of them shade over each other. So Peyton, what is true about where the shading is together? So you're saying that these here that I'm coloring with my black marker, those solutions are true for both inequalities. Hey guys, guess what we're doing today?
That's what we're doing.
Yeah, get out your student journals. Okay, so first of all, this is our last new lesson of the semester. You're excited? Okay. Because on Friday is our test, and then next week is our CSA, which is our final, okay? Now, a system of linear equations, inequalities, okay? System of linear inequalities. Yesterday, you graphed 1 linear inequality. A system is more than 1.
I got it right. What is that? 164.
Sorry, you didn't read my mind? Page 160. Okay. Now, with what I asked you to do earlier, we noticed that when we graphed 2 of them together, they both had shading that overlapped, right? And where the shading overlapped, that's when they satisfied both of them. So when we talk about the solution to a system of linear inequalities, okay, we're talking about any points that satisfy both inequalities. Visually, it's where our shading is going to overlap. Oh, points, I was lazy. Points, sorry. So if a coordinate satisfies both of them, it's a solution. Okay, and we're going to notate that graphically by shading. Okay, so like we did in our warm-up, okay, We're going to graph one inequality. We're going to graph a second inequality. And I'm going to look for where is the overlap. And wherever the overlap in shading is, I'm going to shade that darker so I know that those are my solutions. Okay? Yeah. Ooh, what do you mean neither of them shade? Like they don't overlap?
Yes, they don't overlap.
Okay, so let's think of a time that that would happen. What kind of lines would they need to be?
Perpendicular. Parallel.
They would need to be parallel. If we had parallel lines and like this one shaded this way and this one shaded this way, then there would be no solution because our shading does not overlap. Correct. I don't think that will happen. That is something that could happen in like your algebra 2 class. We're gonna be pretty basic here. Okay. That was an excellent question though. Okay. All right. So let's turn the page and we're gonna go to number 5. Okay. We are doing what we did yesterday twice on one graph. Okay. So like this guy right here, I need to graph the line y equals -2 with a dotted line. Okay. Careful, Gavin. Y equals -2. What kind of line is it? All lines are straight. Don't tell me straight.
Horizontal.
Thank you. Horizontal.
That scared me. It's a spherical one.
I just always giggle when someone says, it's a straight line. All lines are straight.
No, there's a curvy line. Yeah, there's a curvy line.
And then it's not a line.
What is it then?
A curve.
A circle.
Okay. Now, is, let's see. Colin, what point do you want to pick to test?
0, 1.
Interesting. And when I plug 0, 1 into my inequality, 1 is y, is 1 bigger than -2? Okay, so I'm going to take my green highlighter. So shade very lightly, please. Shade very lightly. Shade very lightly. Now, over here, we need to graph the line y equals 3x. Is this already in slope-intercept form? Yes. Our y-intercept is 0. And our slope, okay, we do have it. Okay, all lines are straight. We have a solid line. Is that what you meant? Okay. Those of you who really like to pick 0, 0 as your test point, we cannot do that in this case. Why not?
Because the y-intercept is on 0, which means 0, 0 is on the line.
0, 0 is on the line. We cannot choose that. Okay. So Preston, different point, not 0, 0.
0, 1.
Okay, 0, 1. And if we copycat, if we test 0, 1, we plug 0 in for x and 1 in for y. Is 1 less than or equal to 0? Oh, which way do we shade? Okay. I don't want to shade 0, 1, so I'm going to shade this way.
Oh, yeah, my bad.
Okay. So since we shaded really lightly, we now can darken our shading in the overlap. Where I am coloring black, that is our overlap. That is our solution set. All of those coordinates satisfy both inequalities. The green ones, the green shading satisfies our first inequality. The red shading satisfies the second inequality. But where they overlap, that's where they satisfy both. Those are the coordinates that I'm interested in. Okay. So when I'm looking at your picture, I need to tell a distinct difference in this area that this is darker than the rest. Okay. Let's look at number 7 on the next page. Okay. There, it's already in slope intercept form. How about you and your partner work on this? I feel like that's doable.
I made it down.
So if my coordinate is 0, 1, I don't shade or 0.
You got the line y equals x minus 2. I think you can. Dotted versus solid line, definitely important.
So, like, why is that graph wrong? Because I looked at Seth's, he got it right. He got the answer wrong and the graph right. And the same graph.
Yes.
I mean, like, I'm not sure if it's right, but like, he
Okay.
has it.
Okay, so like if we solve for y, we get y equals negative 4x minus 4.
Okay, so I can do it that way.
Yes.
Okay.
And then this one, you like just drew a line.
Yeah.
Okay.
Because I
Okay.
honestly didn't understand how to graph it, so.
Okay, yes, solve for y. I think solving for y is gonna be your best way.
Wait, what?
So, for some,
Yeah.
like for this one, if it's correct, which way do you shade? Like, how do you
You wanna shade the correct. Shade the ones that work. Don't shade the ones that don't work.
I don't get it. Like, which direction?
So like, your point was 0, 1.
Yeah.
So here's 0, 1. If it works, I want to shade towards 0, 1.
Oh, okay.
Is that better?
Yeah.
No, it's greater.
All right, I would like to go ahead and bring your attention back together. So I just graphed the lines. I didn't do any of the shading. Check me. Do you agree with my lines?
Yes.
Okay, well, that's good. Okay. Now, Seth, what point did you test in this first one? And did it work? So since 0, 0 worked, on the green line, we're gonna shade towards 0, 0, right? Okay, we want to shade towards the ones that work. Okay, now notice how this first one I have a solid line, but the second one we have a dotted line. Nirvan, how did I know to do that? Okay, since there's no equal here, we need a dotted line. Okay, Aiden, what point did you test for this second inequality? Okay, and what happened with 0, 0? Did it work? Yep. So my red line, we need to also shade towards 0, 0 like this. Okay. Do we agree with that? So our overlap is right here. That looks about right? Yeah. Okay, cool. Okay. Before we part ways, we're gonna go through number 8, just so we can go through a couple of problems that are not in slope-intercept form. Okay, so for the purpose of graphing these, let's just worry about, like, I'm gonna do this one in green. I love color coding things. I don't know if you've noticed that. So 2x plus 3y equals 6. Let's just make it an equals for right now. And what do we need to do to help us graph this? Okay, we need to get the x over there. It still said, let's subtract it. So 3y equals minus 2x plus 6. Yeah. And if we divide both sides by 3, then we have negative 2/3 x plus 2. That's the line we need to graph. Aren't you so glad that in chapter 1, we learned how to solve literal equations and we did all of that work so that now when we have to solve for y, it's just not so bad, right? You remember when you thought this was scary?
It still is.
Oh gosh. Oh gosh. All right, so here is my, what do you call it? Y-intercept. And then my slope is a negative 2/3. Does that look okay? Anything special I need to do with this line? What? It's a dotted line. That is definitely what I was going for.
Oh, Dad.
Don't know what you were saying, but.
I said eat cheese.
Okay, so let's come back to our inequality. Our inequality. Nirvan, pick a point, any point. And does 0, 0 satisfy? Is 0 less than 6?
No.
Yes.
I don't believe that.
So I want to shade towards 0, 0. Very lightly on your paper. Very lightly. Too long.
Talking about the ninja stuff you made.
Okay, so now I'm going to change this to y minus 1 equals negative 2x. This one's not that much work. What do we have to do?
You gotta add the 1 to the other side.
Add the 1, so we have negative 2x plus 1. Okay, so I have a y-intercept of 1 and a slope of negative 2, right? And I'm going to make it a solid line since I have that line with my inequality sign. We have the equal. We can be on the line and still be safe. Okay. Okay. Huh. You want to pick 0, 0? Does 0, 0 satisfy our inequality? We would get -1 over here is greater than or equal to 0. I think that that's a no. So we need to shade not towards 0, 0. So here, what? Are you sure?
Yes.
Okay. Away from 0, 0. What was? Okay. Okay, how do you feel?